two reasons. One of the reasons is that we, in Danfoss, we want to support this uptake of natural refrigerants and the sustainability behind that movement in natural refrigerants. And then for the second reason is that it's very interesting for us to come and see how this part of the globe is developing in regards to natural refrigerants. And so it's very interesting to see our peers in the industry do what they do, see how some of our customers and potential customers, and also some of what we look at as the end users, like retailers, in which direction they are moving and the Asian market is different to, for example, our European market or North American market or Latin American market. So it's very important for us to be present and understand. The next 5 years, I think, from a Danfoss perspective, I think it's volume. I think we will see the volume will start to come on different solutions, and that will break down into components coming from us and our peers. So I think we will see that now it's kind of at the point of no return, which I said before, that there is an acceptance that CO2 is a good refrigerant for the food retail industry, but also many places in industrial refrigeration. And these two places are very important for Danfoss. So I think we will see that more end users will, or end customers will accept that CO2 is a good refrigerant, and they will start investing in equipment using that refrigerant. And then, of course, over a 5-year period, it's not that carved in stone what exactly will happen. But I think we will see some technology developments making it even more attractive. In the near future, we are having, from on a valve side point of view, we are coming with new transcritical valve, which will incorporate more features within one product, making it better for the OEM to when they in their production are producing the systems. They will have to do less work, and then we also do it more simple to service. And hopefully we are kind of just extending a range of a valve where we make a new extension to that range, making it larger, fitting into larger equipment. And then also we are trying with that product to make complexity reduction for our customers, so that they can go with less code numbers. And then a little further ahead, this product I just mentioned is to be released during the end of 2015, beginning 16. And then a little further ahead, we will bring a 3-way heat reclaim valve, as we see there might be a need for more sophisticated, or at least more a valve where you have more control of what you're doing in your heat reclaim cycle. So we'll be bringing a product there, also fully serviceable. For the longer term, also on the valve side, on the mechanical side, we have a ejector solution coming. We are not quite there yet in how it will exactly look, but we are right now doing field testing, and we have very promising results. And we work with some of the most capable OEMs and end users in the industry to try to understand exactly what the potential is here for the customers. I think they act very responsible. We have seen some of the major retailers in specific and really taking CO2 on board and making it possible for all of us to be in this area. So it's very interesting to see that some took the early move on the technology uptake curve, and they also, I guess, some of them paid some penalty to do that, but they made it possible for the rest of us to participate in this, and that has really made a huge difference. And now I think there's no larger retailer across the globe who do not know about the CO2 as a refrigerant, either in the cascade system or in the transcritical system. So I think we have seen very responsible retailers taking their share of ensuring the uptake for this technology. Even so much that we see that also in industrial refrigeration that it makes very good sense. So I think that those knowing about the refrigeration technology, they are not in doubt that this is a viable way to go in many applications. I don't say that it's the right solution for all applications by far, but where it makes sense, it makes often very good sense. When you test, and I also mentioned that we wanted to understand exactly where in the industry it fits this product or these kind of products. So when we learn that, then depending on where they fit, there can be different ways that it makes sense to commercialization of the product. So we don't have a fixed time on that. We work to prove that it makes sense. We have already proven in labs that it makes very good sense. That the good thing is that you can most likely, or you can reduce your energy cost in a system, and even from especially in hot climates, it's very obvious where it makes very good sense with the ejector. But also your installed capacity can go down, meaning that the first cost of the system is in many or often a very good solution where you then can lower, for example, your compressor capacity. So meaning that you need to buy less compressor capacity for a pack shooting your supermarket. To give a concrete example, often if you are in a climate where the ambient temperature is fluctuating a lot, then you have to dimension your capacity of your pack system in a way that it's able of running also in the hot season if it's a transcritical system. But you may only use that full capacity of your compressor capacity during a part of the year. So that means that if you put in an ejector, allowing you to lower the amount of compressor capacity, and that ejector will help you on your peak load during the year, you can buy less compressors. Then of course the ejector has to be more, it has to make sense in an economized way, but we will figure that out going on. Yes, I see it develop very, very good. I see we have there are some very skilled OEMs out there, which are using either our electronics and also our peers, and they are totally on top of how to make a system for the retailers so that they get the best energy efficient with the technology available right now. So right now, where you don't see a huge availability of ejectors, parallel compression makes very good sense. And if you look more into the details of ejectors, you'll see that also ejectors need a parallel compressor. So it's an add-on for additional efficiency. And that's, I think that's the new thing with CO2, that we are not waiting for the next refrigerant, but we don't have the end solution of all the CO2 solutions yet. There might be something new. The good thing is that it's already proven that the transcritical cycle is good for many retailers, and when you go to a hotter area, maybe a cascade system is good for you. Then with parallel compression coming into the game and later ejectors, or let's say expanders, then we might move that line further south or into hotter climates where transcritical makes sense. And that, depending on your store size, your store location, do you have a rented space, do you own the place, or do you also need heat reclaim, or do you have a heat already supplied from where you rent your store location? All of these parameters, they play a role in what makes sense for that specific retailer in that specific location. And the OEMs are much better than Danfoss to guide the retailer in what to choose. We at Danfoss, we just make sure, or try to make sure, that we are offering the best technology, allowing for that lower energy consumption, and at the same time making sure that we have food safety, because that is our main priority. First comes food safety, then you can have air conditioning run of your parallel compression, then you can get heat reclaim run of your transcritical cycle, and etc. So. Now I'm not so much into compressor pricings because we don't have compressors for CO2 in Danfoss. But it's if you need to mount a parallel compressor versus not having one, of course you might need to buy additional compressor capacity, and then of course you need to make sure that the energy that you save equals that payback, shows a good payback. So if you are in an area where you don't need the parallel compressor that much of the year, maybe the cost of that setup is different. From an electronic point of view and from a valve point of view, actually, I don't think there's so much a difference. We offer the products anyway what they want to do. They can switch, they can have parallel compression or not. So we just make sure that it can be activated, because the brains in cutting parallel compression in and out, and how before you cut your parallel compressor in, you also need to on your gas bypass valve, you need some control before it makes sense cutting the parallel compressor in, because it cannot run from 0 to 100%. So all of these brains comes from Danfoss controllers or our peers in the industry offering controllers doing the same. So exactly how it influences on cost, it's difficult to say. But an interesting aspect is that if you have a retailer where parallel compression makes sense, and he wants to run air conditioning from his pack, meaning that he is chilling his water for air conditioning between when he comes down from the gas cooler into the receiver. Maybe he takes some cold out for chilling, then he produces more flash gas, and he has to get rid of this flash gas with his parallel compressor. Then of course he has to invest in that part of the system being more expensive in his refrigeration system, but on the other hand, he may save a small chiller or air conditioning unit, and that is up to the retailer to lay that out, this cost picture, and how the demographics is of his cost, and then from there see what makes the most sense for him.